My name is Arthur Needham, Director of Vitruvius Conservation. My talk today is on mortar trials carried out at Lancing College Chapel in West Sussex. We were asked by Michael Drury of St Anne's Gate Architects and Jeremy Tomlinson of the Lancing College Chapel Trust to carry out mortar trials to develop a durable and sympathetic mortar. Testing of historic mortars and stones were carried out by Peter Ellis of Rose of Jericho in conjunction with Nick Durnan. Nick also developed the mortars for the trials. Additional consultancy was provided from David Odgers. Environmental monitoring and salt iron testing was carried out by Tobit Curtis. Jeremy Tomlinson, the chairman of the trust, has been involved with the chapel's conservation for many years, which has been very useful for discussion. Myself and Philip Scorer carried out the mortar trials and rope access. Mortars were trialled internally and externally on the south clerestory. External samples were applied to columns at sill level for ease of access and future inspection in summer 2016. Columns are spread over the ledge, and exposure in this location is significant as it's so close to the English Channel. Mortars were checked after 10 months, 14 months, 38 months and 60 months. Internal trials were carried out in bays 8 and 9 in the centre of the clerestory in autumn 2017. Access to the inside was considerably difficult as we needed to feed ropes through from the outside and then climb up to gain access to the ledge. These mortars were checked after 12 months using a cherry picker in conjunction with the bi-yearly inspection carried out by Michael. 2 samples placed on top of ethyl silicate consolidant were carried out in the South Solar in summer 2018. These were checked yearly. The trials included the use of several binders including quicklime, lime putty, natural hydraulic lime and cement with hydrated lime. The pozzolans used were metakaolin and buff brick dust. The aggregates used were charred stock silica sand and Morton Cullimore limestone sand, and the consolidant was Wacker OH100. The situation at Lancing offers an interesting environment for mortar trials. In 2008, a major repair programme was completed in which the ferramenta to the south clerestory windows were re-tipped and replaced. Mortar repairs were carried out comprehensively using natural hydraulic lime. However, these were decaying very rapidly due to the presence of chlorides in the mortars. This was confirmed using salt iron testing carried out internally. This presents us with fascinating results, as the decay patterns of the mortars are so clearly accelerated in comparison to a more common and less exposed environment. As much of our work is rope access, we tend to work in exposed locations, but we've never encountered mortar decay as dramatic as this. The following slides will help illustrate this. The timeline of these slides starts with the earliest inspection top left, next inspection top right, and last inspection bottom right. Where the timeline stops at 38 months, it will be because by then it was almost fully decayed. So here we have sample 11 on the left column, 3:1 Morton Cullimore to lime putty with 10% metakaolin. And on the right column we have sample 12, 3:1 Morton Cullimore with lime putty and 20% metakaolin. And the inspections are at 9, 14 and 38 months. Here we have an internal sample inspected after 12 months. It's the same as the recipes from the previous slide. However, the concentration of lime to sand was upped from 3:1 to 2:1. So top left, 11B is 2:1 Morton Cullimore to lime putty with 10% metakaolin. Top right is the same recipe with fibres added. And bottom left, got 12B, which is 2:1 Morton Cullimore to lime putty and 20% metakaolin. On the right, the same recipe with fibres again. Here we have sample 13 on the left column, which is 3:1 charred stock to lime putty with 10% metakaolin. And on the right column we have sample 14, which is 3:1 charred stock lime putty with 20% metakaolin, with inspections at 9, 14 and 38 months. Here we have sample 16, the upper of the two, which is 3:1 Morton Cullimore and lime putty with 10% metakaolin. Then the lower of the two, sample 15, which is 3:1 malted Cullimore, lime putty and 20% metakaolin, with inspections at 9, 14 and 38 months. Here we have sample 3A, the upper of the two, which is 4:1 Morton Cullimore and quicklime with 10% metakaolin. And then the lower of the two, sample 4A, is 4:1 Morton Cullimore to quicklime and 20% metakaolin. Inspections are at 9, 38 and 60 months. Here we have sample 3B, which is on the left column, which is 3:1 charred stock and quicklime with 10% metakaolin. And on the right we have sample 4B, which is 3:1 charred stock quicklime with 20% metakaolin. Inspections here are 9, 38 and 60 months. Here we have an internal sample photographed after 12 months. It's the previous two slides with recipes of sample 3A, top left, 4:1 Morton Cullimore to quicklime with 10% metakaolin. And then top right is sample 3B, 3:1 charred stock and quicklime with 10% metakaolin. And bottom left, sample 4A, 4:1 Morton Cullimore and quicklime with 20% metakaolin. Then bottom right, sample 4B, which is 3:1 charred stock to quicklime and 20% metakaolin. These are the samples we put in the South Solar using consolidant. Note the samples on the left were with consolidant and the sample on the right is without. On the left, the top left is 3:1 Morton Cullimore to quicklime, 10% brick dust. Then the middle one is sample 3B, which is 3:1 charred stock to quicklime with 10% metakaolin. On the right, it's the same sample. However, it's notable that there was a significant area of damp on the outside of that mullion due to a blocked downpipe. A slightly different situation to the one on the left. Here on the left column we have sample 24, which is 116 quicklime to NHL 3.5 and charred stock. And on the right, sample 21 is 129 cement to hydrated lime to Morton Cullimore, with inspections at 14, 38 and 60 months. Here on the left column we have sample 23, which is 116 quicklime to NHL 3.5 to Morton Cullimore. And on the right column, sample 22, which is 129 cement to hydrated lime to charred stock, with inspections at 14, 38 and 60 months. Here we have an internal sample relating to the previous two slides. On the top we have sample 23, which is 116 quicklime to NHL 3.5 to Morton Cullimore, and sample 24, which is 116 quicklime to NHL 3.5 to charred stock. The upper of the two samples on the left column, sample 10, is 3:1 charred stock to quicklime with 20% metakaolin. The lower of the two, sample 9, 3:1 charred stock to quicklime with 10% metakaolin. And then on the right column we have sample 8, which is 3:1 charred stock to quicklime with 20% brick dust, with inspections at 14, 38 and 60 months. The samples from the previous. Here we have two of the samples from the previous slide put on inside. The top one, sample 9 at 3:1 charred stock to quicklime with 10% metakaolin. The lower is sample 10, 3:1 charred stock to quicklime with 20% metakaolin. These two samples are both with NHL 5. Sample 19 on the left is with Morton Cullimore. Number 20 on the right is with charred stock, with inspections at 14, 38 and 60 months. On the left column here we have sample 17, which is 3:1 Morton Cullimore to NHL 3.5. And on the right, sample 5 is 3:1 Morton Cullimore with lime putty and 10% brick dust. Inspections taken at 9, 14 and 38 months. Here on the left we have sample 18, which is 3:1 charred stock to NHL 3.5. And on the right column we have sample 6, which is 3:1 Morton Cullimore lime putty with 20% brick dust. Inspections here at 9, 38 and 60 months. Internal sample here after 12-month inspection. On the top we have sample 17, which is 3:1 Morton Cullimore to NHL 3.5. And on the bottom, sample 18, 3:1 charred stock to NHL 3.5. Here we have sample 7, which is 3:1 charred stock with quicklime, 10% brick dust, with inspections at 9, 38 and 60 months. On the left here we have sample 2, which is 3:1 Morton Cullimore to quicklime with 20% brick dust. And then on the right, sample 1 is 3:1 Morton Cullimore to quicklime with 10% brick dust. Here an internal sample after 12 months. Sample 1, 3:1 Morton Cullimore to quicklime with 10% brick dust. And 2, 3:1 Morton Cullimore to quicklime with 20% brick dust. So putty mixes have performed relatively weakly, decaying at an impractical rate. Internally, when gauged with NHL2, putty performed pretty well. The hot mixes have performed reasonably well when used with brick dust, however when used with metakaolin tended to set too hard. When gauged with NHL 3.5 using the silica sand, the resulting mortar had a good balance between durability and sacrificial qualities. Natural hydraulic limes have performed well with good durability and erosion rates. Cement and hydrated lime mixes have performed surprisingly well with good bonding to the stone, showing little sign of the typical differential erosion you may expect to find between soft stone and cementitious mortars. It may be that in this environment the bond these mortars have with the stone offers better protection, as opposed to the exposure a sacrificial mortar presents to the substrate when subject to wind erosion. The depths of the mortar repairs are not directly comparable, and the stone is also variable. They do, however, give a good indication of performance in this environment. Deterioration patterns may well continue to vary and will be monitored as part of our ongoing maintenance programme at the chapel. Whilst the more dramatic results highlight the necessity for mortars used here to be durable, it is important that the mortars used in the future maintain sacrificial qualities also. The results have given us a good range of behaviours to inform development of an optimum mortar composition. In our yearly programme, we've continued to use natural hydraulic limes until this year, when we have used a hot mix gauged 50-50 with NHL2 in a very exposed situation. This mortar was very practical for use on the ropes, showing very little sign of shrinkage despite going into some particularly large joints. That's the end of my talk. Thank you for listening.